We'll just start with this slide just to warm up a little. Um, it's talking about data. Data in the sense in which I'm going to be applying it or mentioning it would include the information as well. So information and data are two separate things, literally, in the sense in which they are used when you're being very specific. So if it is a data, it's mostly numerical or something that is tangible, something that is going to represent or give an idea of a decision or statement of facts or denial of facts. So the data has that nature to it. When we talk about information, we are sort of looking at things from the part of exploring something or finding something, discussing something, picking up ideas. So it does not have like a tangible nature in that sense, that it normally is something that is subjective. So information and data will be using interchangeably. So for us as researchers, it means the same thing. We'll just call it information sets or information. I want to address the attributes or qualities or characteristics of a data or a data value that is attached to the information sets you collect or the actual data that's collected. What we look at when we are addressing the collection of information, besides primary and secondary source, that sourcing is another aspect, but the value or the consideration of how that data gains the credibility or maintains its integrity has certain attributes. One of them is reliability. This is the classic question for the exam. They're going to ask about the value attached to a data, or how would you consider the relevance, reliability, accuracy, the currency of time, the purpose or the objectivity of a data that you're using. So reliability, relevancy, do I have to explain each one of them? I think not. I'd say that you can pretty much grab from so far whatever we have learned. It seems that, and besides, the wording themselves explains it all. Okay, so it has, the most important thing for me is that it should be purposeful. That means it should fulfill the objective of your research. It should have enough reliability and relevance that it becomes purposeful. The objective of your research will define what level of accuracy or what level of relevancy is required. Okay. That's how we're going to add the value to the information sets and the data that's collected. Now, this chart is important. It's in your book as well. I did find one inaccuracy in this, but probably doesn't matter. I'll mention it later when we go through it. So let's look at the data. The data we are looking at is in the sense of both information and data together. So data is going to flow in the direction of how the arrows are defining certain things or certain modes, values, and certain processes that each data set goes through. First of all, the data itself is to be considered in the way it is collected or the different ways in which it gets collected. There are different methods attached to it, and these are boxed here, and you could see that they're listed as well, 1 through 6. So these are just data collection methods. And of course, Data collection methods will also depend on the type of analysis that you plan to do. Like for instance, certain data sets for certain type of analysis should have a quantitative nature. Others would have a qualitative nature to it, or that's something that is subjective or would have an element of bias to it. So the collection method would be different. Sometimes you do a mixed method, which includes both the qualitative and the quantitative data sets. So on one side, you could see that these are the data collection methods. On the other side, you could see that the data types are defined. Now, when we are talking about data types, of course, qualitative, quantitative, two that have to be distinguished. Not that we are talking about primary source of data or secondary source. We are just defining the nature of information, nature of data, which is divided into two sets. Then there is a mixed method as well. And as we move a little bit further, the next process after collection of data and after separating it into qualitative and quantitative, which is the nature of data, then we plan our analysis or what type of analysis we require. Analysis requirement will depend on the objective of research or what should be the outcome. What type of conclusion is to be derived? Is it a problem that is to be solved? Or is it a fact that needs validation? Or it is a new research where you're trying to find something or create something or build inferences. Okay. So analysis can have different nature and based on all that I said earlier will define your analysis methods. Now in data analysis, we look at analysis types. Okay. Types versus methods, two different things. Types first, qualitative. What type of qualitative analytic methods are well known or is considered basic, fundamental, or required some sort of conceptual understanding? Not that we are getting too deep into the different flavors, versions, because see, analytics can involve all sorts of reporting or all sorts of analysis. It could be a relational data or it could be totally unrelated data that needs to be analyzed. It could be a type of analysis that entails observation only. That means it is, again, it is a more personally derived conclusions or inferences. So there could be different subsets of analytic induction, for example, in qualitative data analysis and grounded theory. So analytic induction, for example, and grounded theory are the fundamentals or general concepts, not very specific, but they sort of distinguish the approach that you are going to take to build those methods and methodologies. The term methods and methodologies in the research world have different meanings. And one has to be very clear about that, because when we talk about methods, it is a method that is generally known as standardized. Methodology can be an approach which may be different to reach the same objective, but the methodology can be different. And then there is another aspect to it that's called philosophies. Philosophies is something that has a deeper meaning, and it is probably been around for hundreds of years as the research originally started, and then the philosophies got developed, and it's sort of philosophies have a way of changing and adjusting to the socio-economic and the cultural things that with time it evolves. So those are the philosophies. But the methods and methodologies is something that there are two different things for us to mention and for us to apply, which is what we'll be doing. as researchers. Philosophies is when you actually are taking a course on research itself. So there is academic value to philosophies. Now, then we've got quantitative analytics also, analysis. In quantitative analysis, we are dealing with numbers, numeric, something more definitive that will not leave a room for any ambiguities. So that kind of analytics are have a different types or different ways of doing the, and again, just like qualitative, coding would have a subset or different methodologies to it, and they are named differently. But generally, what is recognized as something for our understanding to have a concept cleared up for quantitative analysis, we'll be dealing with things like coding, memoing, integrated diagrams and sessions, and focus groups. Focus group, this is the error that I was referring to. See, focus group is set here in quantitative when actually it belongs to a data collection method. So this is an error in drawing this diagram. But anyways, just so that I point it out and you know, I'll fix it later. Next, moving from the analysis types, we are going to look at the methodology of how we are going to approach it. We are not going to address the qualitative part, but we'll deal with quantitative right now. The data analysis method in qualitative are basically driven by the way you are going to set your surveys or you're going to obtain samples. We'll deal with this, but the approach will be different. But for now, let's just look at what quantitative methods are. And the quantitative methods, one of them is called statistical methods. And I am sure that most of what we learned in statistical methods, you probably would have already encountered in your school days or recall from your school when you were doing maths and stats and trigonometry, geometry. So you could see that some of the named methods in statistics would ring a bell, like central tendency, mean, mode, median, the standard deviations, range, and things like that. We are not here to learn a lot about the methods themselves, but the idea is to be familiarized with the different ways in which qualitative and quantitative analysis take shape, and for you to get an idea so that if you need to dig in further, deeper, and have to somehow deal with methods and methodologies of analytics or the approach you're going to take, then you would at least be able to relate to it or know what somebody's talking about. Now, let's come on the right-hand side of this diagram. And this arrow where it's mentioning data collection. There are methods of collecting data, and we will be mostly looking at them from the online research point of view. Even though the roots of all of these that are mentioned here in this box are embedded in the conventional research, or these wordings are pretty much related to the conventional methods or how they're described in research terms, but we will have to visualize them or to somehow connect it with using the same methods, but doing it on the internet as online data collection. So observations, we will probably be looking at social experiments, like most of the videos you see, some of the ways in which the social experiments are done these days, where the observer is sitting making a video or somebody is recording, and all the actions, interactions, events that are staged, how they are bringing information to you. that you can later use as an observation and make your own judgment for, for collecting that information or its interpretations. Surveys and polls. So we're talking about online surveys and polls, online interviews, online focus groups. So they just add the word online, except in 5, which talks about document studies. Document study, as the word itself says, that it requires for you to do some due diligence, look into actual documents or scripts or anything that is available to you that would require a detailed analysis and basically going through facts and cross-referencing them, and the ones that you use while you are trying to create some thesis in academic world, or where you are asked to do some research for writers. Somebody is writing an informative article, they might need some document research. Case studies. Obviously, case study means the realistic situations or the scenarios which simulate something that is within a test environment and eventually brings a solution to a staged problem. So we have these data collection methods from the online perspective. 1 through 4 is what we would be discussing mostly. That's to do with online internet collection methods. Surveys and polls we will be discussing in detail. So surveys is something, and surveys and polls is the next topic that we will be doing. But right now, we want to know what happens after we collect the data. So data collection in itself has got a methodology which requires a method or a known methods to be applied, which is recognized industry-wise. It's not that you're creating it, or you're not like, usually you don't do random sampling. You don't just go out and just collect sentiments or any kind of surveys that you do. You don't do it randomly. You still have some target subjects to deal with or to collect that information. So it's never truly random. So sampling is done based on certain homogeneous attributes, something that defines characteristic, or there is some similarities, something that gives it a symptom common to the group, and that group is derived from what we called a population. So population would have a mix, and here I'm referring to people, not anything other than human subject. So for the ease of using it or applying it, as part of the sampling, we will use human samples and people only. So if it's a huge population and it has a lot of people with different walks of life, different background, profession, age, gender, all that is a huge population. So to derive sample out of that would mean that now you need to bring that volume under control by first of all reducing that sample size so that it is more under control environment and you are physically able to conduct some sort of survey or research on. Second is that they should have some commonalities or something that sort of gives it a unique position in the sense of how they would react to a certain set of questions or for whatever type of research you're doing. So sampling is the most important part. When we, after or during collection of data, we would first of all have to derive samples. Sometimes the sample cannot be obtained easily, so there is a lot of factors that so there is cost involved, there is a reach involved, reach issues. then certain surveys may not be able to find the group of people, or if the group of people with the same set of issues, problems, especially in clinical trials, may not be willing to participate. There's all sorts of issues. But here we just focus on why, what type of sampling are we talking about. So there are basically, here we are talking, when we say type of samplings, we are looking at the methods of sampling. The first method is called probability sample, and the other one is a non-probability or non-probabilistic sample. If you recall from what you have learned about probability, I'm sure most of you would have a general idea. Probability means a chance of something happening or not happening, or likelihood of some occurrence to happen, and certain occurrence for not to happen, or that could be the minimal probability of something not happening. Okay, so the probability would also be defined as an equal chance of one of the two. It's a simpler way of expressing, like when you flip a coin, so there is a head and a tail. So the both head and the tail, when you flip it up in the air and before it falls, it may have a chance of 1 out of 2 to happen. So that is a simple probability, or the either the head or the tail is going to come. So that equal chance, or 50-50 chance of one of the two coming, is probability. And that probability is easy to figure out. But what happens if you have a lot of variables? What's going to happen then? The chances of something happening or not happening. So that is, prior to collecting the sampling, you have to really look at the option of whether or not to use a probabilistic sampling or to use a non-probability. So non-probability is something that's not using the probability or the chance game. It is already predefined, or you have already figured out the sample size and the target sampling. So that's non-probabilistic. Now probability sampling comes in as simple random sampling, stratified, systematic, cluster, multi-stage, multi-phase. Number 6, multi-phase, is actually phased out. We don't use it. It's not only not practical, but it would require a lot of depth of understanding. So we didn't think it was something. It is mentioned in the book, but it's not covered extensively. Okay. Non-probability samples are convenience-oriented sampling, purposive, quota-based, snowballing, volunteered. These are just fancy names of something which is very easy to understand. There's no complication on this side. On the left-hand side, where the probability sampling needs to be obtained, this is where you will have to make a decision. You have to be very careful in how you're going to derive your samples out of the population. Because if your client, for instance, who was asking you to do the research, they would be particularly concerned about this sample, the quality of sample, type of sample, and the strategy what made you select those sampling techniques, or given the scenario or the situation, if that sampling technique fits into the purpose of research or not. So these are the questions that you will need to answer. So for this alone, you should have some sort of understanding of how to approach the probability sampling. Even in non-probability sampling, you are accountable for it, but understanding it is not as difficult. So that's what I mean when I'm saying that it's simple to understand the non-probability side. Okay. So any questions on this? Now, I think I forgot to mention the different data types that that defines, let's say, the qualitative data. It could be binary data. So the nature of data, like Would it be, whole numbers or fractions? Those are differentiated as binaries or nominal. Ordinal data is organized. It has some arrangements. Interval is a set that, well, we'll go through it later, but just giving you an idea that this is what the qualitative analysis entails. Then quantitative has two sets of data types, which is continuous data and discrete data. Anyway, let's just move on then. Okay, so qualitative data. Exam question, always differentiate the data type into qualitative and quantitative. So if it is personal observations, emotions, sentiments, interviews, opinions, suggestions, trends, season, things like that, which is, more to do with feeling or, observations, or how you describe certain things, more linguistically than numerically speaking for quantifying, then that part is qualitative. Quantitative is straightforward, height, shoe size, etc. All of this thing. Is my video gone? No, it's still there. Okay. Now, so okay, it's starting from here. All right, let's just start with data types. I don't want to miss slides. I have to, otherwise I'll lose track. So wanted to start with the sampling methods, but I'm going to let's start with the data types. So the data types are broadly distinguished into two kinds if they are to be quantified, if they are that they have got numerical values to it. One is called continuous data, which means that it could be a fraction or something that ends with point, whatever. So it has that nth value or something that can be expressed in fractions. That means they don't have to be whole numbers. Okay, so that is continuous data. Example is the best way to understand. The driver completing the fastest lap of the race, winning by 1 meters by covering 1 meter in 12.34 seconds. So this is continuous data. Discrete data is something that has to be expressed in whole numbers, 1, 2, 3, 4, and not 1.3, 1.2. Like children, kids cannot be 2.5, or pets can't be 1.3. Again, when it comes to discrete data, what we are trying to describe and distinguish between continuous and discrete is based on the service that we develop, the way that we ask questions to collect information. So if it is to have a discrete value, then they have to be in whole number. So whole number could mean yes is equal to 1, no is equal to 2, 1 is equal to male, 2 is equal to female. So that is discrete data. So if somebody is saying that, hey, how do you intend to conduct the survey on this and that issue, you could say that we will definitely be using discrete data sets, and for that reason we will apply so and so method. So it's just linguistic. It's just the jargon of how you express or present yourself as someone who understands research work. So continuous and discrete, that's the only thing you have to remember. Nothing major. Then the qualitative data types. This is where we are going to have to distinguish it into all these different ways or methodologies that we adopt. Binary data collection, nominal data. So again, depending on the situation, depending on the subject matter and the type of information, you will have to figure out if it is going to be binary, nominal, because based on these data, you're going to do analytics. Analytics are directly related to the nature of survey or the type of data you have collected and the value of that data. If we put it all together, the next step will be for us to then devise analytic method. Okay, so binary, nominal, ordinal, what are these? Binary Data is something that has two extreme values, which are definitive, even though it's qualitative, but it can be translated into numerical values. In a way, it is definitive in answer. There is no middle grounds. Like if I say I like something or I dislike something, okay, then it has got two values, nothing in between. May like, how I feel, bored, stressed, or um, you know, feeling gloomy. So three different type of sentiments or anything that is describing more than two values, qualitative values, is not binary data. Binary is just two values. Then we've got ordinal. Ordinal means that it is sort of described in a way that it has more than two values, which means the two more variables, yet all those variables are interrelated. So the subsets or the main sets of the question or anything that has to be answered by giving it a sentiment description or like similarity description, whatever it may be, would have multiple values to it, but they have to be ordinal. That means they have to be interrelated or have to be the subsets of the same problem or answer to the same question, but in 10 different ways or more than two different ways. So if I have something, how likely are you to recommend our services to your friends? Very likely, likely, neutral, unlikely. So it has all these values. Most of the questions that you create on the qualitative data collection, especially in surveys, usually are ordinal approach or ordinal data. My watch keeps hitting my table today. Okay, maybe I need a little bit more space. Okay. So this is qualitative data, ordinal style. Okay, nominal data or unordered data. Unordered data means that it is describing something which may not be coming from one, or it is not an answer for one individual. It's not a personalized answer. It is more to do with describing something. As an example, what color hair do you have? Brown, blonde, black, rainbow, unicorn. So it doesn't have to apply to like personal liking, disliking, feeling, or nothing of that sort. It's more to do with describing something. So a science category for identifying purposes. So male is equal to 1, female is equal to, the numbers have no value, but it identifies the difference between the male and female population. Okay, basically they're labels, and nominal comes from name to help you. Okay, so what it's saying is that basically it's let me just make a little bit of correction here. Instead of male and female, I would say that I would use 1 is equal to male, okay, and 2 is equal to female. Okay, so it's going to be like this. It's the other way. 2 is equal to female. So what I'm saying is, when I collect this type of information, what is your nationality, what color hair you have, it's called unordered because it is not really describing something that is coming from, or it is assigning a value. It is not like an ordinal data where you're giving your sentiments. It's about you, about an individual's about a set of answers that sort of relate to each other for the same type or the nature of information. So I don't know how else to put it, but let's suppose I used instead of brown, I used something like likely, blonde as less likely. So when I had these kind of attributes as an answers, it was more to do with the ordinal data. When we are talking about nominal or unordered data, we are describing some individual or some entity, something. So, so this means that this is slightly different, or nature of this is different. And to make it easy, like for people to understand, like brown in the machine language would have a value 1, blonde would have a value 2, black would have, so you can give different you can quantify it differently, yet it will translate in the same way. Okay. Meaning that it is easy to quantify, or you can give it a number also, just for the machine to understand. So this is what you're going to do when you're using nominal data. When you are using ordinal data or unordered data, when you're using ordinal, you don't want to do that. You cannot give 1, 2, 3, 4 to it. The machine would not be able to interpret that, because those are sentiments and feelings, but this is more definitive. Brown is a color, so that is more definitive. Nationality is definitive, so you can always quantify or put a number against it for the machine to understand. So that will be unordinal data. Then we've got interval data. Interval data is when certain values or certain sets are not conclusive of the results from that observation, and you need more than a few observations to occur. You will be talking about interval data. Interval data means, like, for example, there is a tennis match and you've got numbers like the first set could be, I shouldn't even have mentioned that, but let's suppose we take this example. Scores in Olympics, it's 6.0, 6.5, 7.0, 7.5. So 1, 2, 3, 4 events would have given all these points to a performer, for instance. So the performance itself would not be conclusive if we just mark it or base our judgment on just one instance of that event or that race. When certain performances require, or certain set of data requires more of the outcomes or scores of the same event, just to make an overall judgment through the collection of that different sets of events. As you could see, 6.0, 6.5, 7.0, 7.5 for, let's say, one athlete, athlete A. Athlete A would be given these different sets as performances, and when they're added together, the overall results of the overall score will define how much of a perfection that performance had. So this is where we have the data when one event is not conclusive, or one instance of something is not conclusive, and different sets of scores are to be included in making that observation. Ratio data is easy to understand. I think ratio simply means the percentage, or compared to, or how many times of one, or how many times against one something is happening. So the ratios, where we use ratios, will depend on the type of observation, which for instance, which does require ratios to understand something, like likelihood of something happening 1:10, or 10 times, or 5:1, or what ratio of something, even the words, certain words, let's say there are 500 words on a page, and a set of words you want a ratio for, which is, let's say, internet, how many times it's occurring on that page. So whatever the number of words are, that would have a ratio or relevance against the total, or out of the total of 500, let's say 20 words were internet. So the ratio would be 20 is to 500, or you could say that it is a subset of the whole, more like a fraction, but not really fraction, because it is number of times that you are matching. So ratio data is very similar to, okay, never mind that. Let's look at, for instance, height is a ratio data. Height is a ratio data if you have a population to compare with. Height cannot be a ratio data alone. So there is always have to be another set or number. It is not possible to have a negative height. Okay, so the ratios don't come in negative. If an object's height is 0, then there is no object. Of course, you have to have something to compare with. So it has to be a number somewhere, which is whole number. It could even be a fraction, but nothing on the negative side, or it cannot be 0. This is a different something. Okay, so anyway, don't get confused. Simplest is scoring 40 points has twice the value of scoring 20 points. So the ratio is 40 is to 20. Okay? And the way you write it is 40, and then you put the colon sign, and put whatever is a whole you put on the left, and whatever is comparable to the whole you put on the right hand side. Okay. So in the sampling language, when we're talking about ratios, we're talking about multiple ratios. Okay, sample doesn't mean that you're going to obtain a sample for as a ratio of one aspect of your answer or your observation, but it has to be ratios that are compared. So sample means that there would be multiple ratios of something. Okay, so 1 is to 2, 3 is to 4, 11 is to 9 could be different ratios of something or a sample. Sometimes you need to do that because you can't get exact numbers. Okay, you can get approximations. Sometimes you do get ratios that are that are different, and they do not relate to each other in the exact sense. So there is a shortcoming when you apply ratio analysis, or your sample brings in sets of ratios. So the ratios have to be collected from homogeneous sample. It cannot be a sample which does not have the same qualities or same attributes. You can only compare ratios when they have same attributes, but they're coming from different regions, let's say. Okay, if it is male and female from Mexico versus from India, then that ratio can be compared. Okay, but it still has to be male and female, cannot be any other attribute. Then data types and data collection. Online, this is more important to know and learn. This sort of techniques are for collecting information that can be either quantified or can have just the qualitative values. That means it could be mix of things as well. Some like in observations, you can have a experimental situation where you are observing a number of people ordering something in a pizza shop, and you can count the number, like how many people walked in, how many were female, how many were male, what was their preference. But when you also want to go ahead and check the attitudes of the server, if it is a male server, how is this person reacting to female customers, female customers reacting to male, what was their sentiments, what was their, how did they appear, were they happy, were they stressed, were they, so there could be a qualitative aspect, there could be a quantitative aspect in the same observation. So what we are dealing with here in collecting data through observations. Now, observation doesn't have to be, see, when we are saying It has to be online. It doesn't, like, you don't have to be physically there. You can be reviewing events. Yeah. You can be reviewing something on the internet. You can create a virtual environment which sets a camera and you're doing observation sitting remotely somewhere, still online observation. Even CCTV cameras will give you observation that is communicated to you through the internet. So in a way, observation can be considered virtually transmitted. Uh, One can be in real time, the other one can be observational. Real time means that you are collecting but not making that decision. You never do research or create any observation that would apply instant decisions or instant research in real time. Research is usually post event, like when it has already happened and you do your observation analysis, it's post event. So observations obviously are recording something that is not in real time mostly. I don't know. I mean, we're not talking about surveillance here. Surveys and polls. Surveys are constructed. There are different types of surveys, but the most important for us to understand the difference between surveys and polls. So in the exam, there is definitely a question that I can think of that talks about the differentiation between the two. To say that surveys are the same as polls is incorrect, whereas the polls are very short questions, don't require a lot of thought. It is usually yes or no. So it is um, the kind of questions that would have a definitive answer. Polls are least time consuming. They don't ask personal questions. It doesn't have the quality that's deeper surveys or surveys that are more detailed questionnaires, and they're crafted in a certain way. One of the differences between polls and surveys is that polls would only ask questions that require a short answer. So it is not extensive, doesn't take a lot of time to do, but surveys are created based on different ways in which you are going to apply your research or the way that you're going to collect your answers. Sometimes you don't ask direct questions. Sometimes the nature of survey is such that it's asking sensitive questions, but not being very insensitive about how they are wording it. So the wordiness of it matters a lot. Sometimes the surveys are structured so that they are deriving some observation or bringing the subject towards getting an answer, which otherwise, if you had asked a direct question, would not have been relayed to you or not have been detailed enough for you to really make it useful. So you sort of create those steps. Sometimes you create traps also, but that's unethical practices, especially when we're talking about ethical ways of collecting information. The method and methodologies both are subjected to the privacy laws as well as consumer rights. And the more the subject is vulnerable, the level of vulnerability of your subject that you've selected would put the onus on someone building those surveys as the one responsible for ensuring that on the sliding scale, the liability would be higher, or the responsibility of the one taking the one taking the survey um, has a higher level of responsibility and a liability legally. So more vulnerable subjects could be elderly population, someone who's not literate about computers, someone who is kind of not, let's say, very smart. The IQs are low. Minors, patients, um, people who are taking under the influence or something like that. So all that matters, and that has a lot to do with the ethics or ethical issue, but the way that you're going to conduct your surveys will depend on how you structure your questions, and that would also be a set of question that could be leading question. That means whoever is exposed to it or has willingly volunteered to answer those questions should not be led into a situation where the surveys would remain incomplete, because let's say out of 10 questions, on the 7th question the subject might start to feel uncomfortable. So those are leading questions, and those leading questions normally land you into trouble because surveys remain half filled. And then there is a informed consent situation. Informed consent means that you have to obtain some sort of understanding or an acceptance, as well as a sort of a small contract that binds or makes both parties, the surveyor and those being surveyed, to have a clear cut understanding of where that survey is going to be used, what would be the outcome of this survey, where that information is going to be sold, used for internal purposes, that means purpose of that search, um, and so on and so forth. So there is a standardized format. In Canada it's slightly different from what you have in US. So informed consent is a piece of paper that is got a that has got a a format that you have to follow. uh, Interviews are more personal. Virtual interviews, when we normally these days we'd like to do virtual interviews. Most important in interviews, and the reason for interviews is that first of all there is an interaction. It is more interactive, where people are able to talk to each other and you see the reactions. So when you're collecting qualitative data from subjects, you want to look at certain things that would be part of your observation and part of your research, and therefore it needs to be presented in a set of interviews, or the environment has to be the actual interviews. Interviews can be one-to-one, or it could be one-to-many, or it could be more interactive. But mostly, let's say it is one-to-one interview. That means if it is something more personal that you're planning to ask, then maybe it's a good idea to have one-to-one conversation. Expressions, feeling, reactions, um, certain issues that a person feels comfortable talking about by looking at each other rather than answering it with the on a piece of paper. So that sort of um, that burden, or that um, that kind of connection that you have in interviews will result in getting better answers. Third reason for interviews is that it can you can actually apply something called grounded theory. Grounded theory means that you have a root of a problem that you have identified. You have an understanding of the subject for which you need to gather the information, but you want to create more questions on top of that, or you want to be more observant, or there could be questions coming out of or in between interviews that lead to other questions or give rise to questions which never thought about. So that scenario is also dealt with when you are doing one-to-one interview, so that it is not a fixed set of questions. It could be leading from one question to another depending on the response and depending on the comfort level of two people. So interviews are really great in that way. Uh, and then we've got focus groups, common scenario, common situation, common backgrounds, talking about issue, or the backgrounds that cross each other, in the sense of how it relates to each other's issues. situations that require experts to interact with each other. And the third person, when you're doing focus group, you never do it alone with you being the only observant. The rule is, and even legally speaking, you if you're doing virtual focus group, there has to be more than one person at least, but normally there are 2 or 3 people who are involved as presenters, or the ones who are the mediators, or the one who takes the role of asking questions. So there is like at least has to be two. One has to be a moderator, the other one has to be the person who is asking the question, and perhaps a third one who is doing the observations or noting down something. So from your side, it involves more than a few people, and on the other side there could be many. I mean, who knows, for the group that you set as a virtual group. Now, virtual focus group is collects both kinds of information. It could be quantitative and qualitative also. So the sampling for creating a virtual group will depend on, or the focus group will depend on the nature of the issue. There is no definitive way of figuring out how many or what should be the size. But normally, if it is online, you cannot have a lot of people. Then we've got document studies. Bye bye, Jim. See you tomorrow. Then we've got document studies. Now, document studies is when you're doing in-depth research on something. Simona Proud would know better, I guess, because she's the one who's doing, I believe you were doing PhD. Weren't you? Are you? Or
yes, but I'm not doing case studies. I'm working on corpus linguistics or database. It's rather quantitative.
Quantitative data.
Applied. Yes, applied. Yes.
So yeah. Go ahead, please continue.
It's actually somehow mixed, because I'm starting from text, then I make an interpretation of text, which is qualitative somehow. So it's mixed.
Mixed, eh?
Yes, but it's a database or a corpus linguistics of texts. It's not a case studies anyway.
So it seems that you are collecting that data to sort of build some sort of analysis or analytics out of it to come up with results.
Yes.
Of some kind.
Yes, exactly.
So is it relational to each other, or it is something that is probably like bullying you mentioned in social media?
Yes. Yes, I have selected some criteria for identification of text, and based on these criteria, I'm making the corpus of text. Then I will analyze the characteristics of text. So this would be the plan.
So basically, you're trying to create tokens, and you're doing like textual database search.
Yes.
Okay, so you are trying to create an algorithm that is going to connect your data with the text, or the linguistics is where you are going to apply your. So the textual search would require for you to have a very good understanding of the textual database, eh? Isn't it?
Yes. Yes.
So you're creating a search engine.
More or less. I'm not an IT specialist, but I'm trying to identify some patterns of words, basically, or combinations of words with Boolean effect. But for having this, I'm starting from texts. You know? Yes.
Yeah, that's very interesting. Eh? That's very interesting. Because this is what I've been doing. Like long time ago, I actually worked on the textual database. You know, I was doing. It's a very deep subject that I was involved in, because I was doing speech to text and text to speech, and creating Q&As and making a relationship between answers and the questions, so that the natural language would be able to translate my thought in the best way possible and bring answers to those questions, and for the questions to relate to the answers automatically. The difference was that linguistic was being converted, meaning that conversational text or the speech was converted to text, and then information from my database or my textual database was to be retrieved, converted back into voice, and that delivered as a phone call or a voice. You know, it's read from text to speech. So this is what we did a long time ago. It's about 20 years, almost 15 to 20 years ago. That's interesting. Okay, so
yes, I'm working only on written texts. I haven't done anything about the speech. So it's just.
so it is theoretically, this is where you're going to theoretically prove that you can actually connect the textual wordings or anything in text to relate to the data sets which you have obtained. Let's suppose there could be numbers or anything that can be brought uh, by writing something in the search. Like if you write something in the search, would you get the kind of information? Is that information retrieval? How are you going to retrieve that information?
Well, do you mean the how the algorithms will be?
Yes.
Yes. So I'm using the morphology, some symbols for example, for noun, for adjectives, or for interjections. So I'm using some symbols, and I'm conveyed the words into these symbols, and the combinations, which supposed to be some utterances in linguistic language. So the combinations will be written as algebraical relations. It would be something like noun plus adjective plus, I don't know, verb. But there will be also subcategories, not any noun. Not all nouns are Boolean. So there will be subcategories of Boolean nouns, Boolean adjectives, and so on. Yeah.
I see.
It's very simple. Yes, it's very simple because my tools are very small as well. Probably in an IT language, this could be written much more complex, in a complex way. But I had only algebraic relations and morphology as well.
So where are you going to use, like, what is going to be the practical use of this eventually? Who is going to use it and how do you use it?
So the idea is to make some lexicons and some algorithms, and if you put them together, you could identify a Boolean word or a Boolean utterance.
Okay, so that could probably be something that, is it part of your academic? Is it academics that is going to use it as a research, or would it be a company or someone that you're working for on this?
No, I'm not working for anybody. It's just my proposal for thesis.
Okay.
And yes, I'm working now on a database. I need at least 10,000 entries for making a valid database corpus, you know.
Mhm. I see. And are you finding the data you're looking for?
Yes, yes. It's not very easy, but it's not impossible. I'm selecting text with at least 30 representations of one word or one Boolean word or one Boolean utterance, combination of words. So at least 30 texts. If there are not at least 30, there is no point to go further in looking for that specific word.
Chris is almost going to sleep.
Oh, I'm sorry. Yeah.
Chris is still up. He looked like he was snoring.
Oh no,
Were
no,
you taking a nap?
what I'm doing is most of the time I'm like this, but what I'm doing is I'm sitting back in my chair.
Right,
And
right.
that's so when I'm like this, it looks like I'm taking a nap, but no, I'm fully here.
All right. It was
I'll even
something very interesting. I was talking to Simona, but I thought it was probably a time for you to take a nap.
oh no. In fact, I'll even keep my microphone on.
All right. Okay, good enough. Let's look at what case studies are. Okay. Now, case study is the study of real life situation of some event or some happening, some environment that you are observing. And case study involves something we call ethnography. Ethnography, in the way we look at from the researcher's perspective, is to understand the behavior of something happening in an environment that is impacted by the social setup, by the social values, the surroundings that gives it a situational value, because it is to do with your understanding of how some of the behaviors are different from one culture to another, or from one event or scenario to another, even where there is a stressful situation, poverty situation, there is some sort of war zone, the behavior of people in that kind of environment. So it requires ethnographic observation, which means that you are deeply involved in there, you are living with them, you are sort of part of what is happening, right? So you understand the values that are there, the sentiments that are there. So you basically are ethnographically inclined to make your observation, and that is where the case studies are done. So that's the case studies, and then what else is left? Okay, so we are done with the ways that you do all sorts of observations and you collect your data. So there are observation techniques, surveys, interviews, focus groups, document studies, and case studies. Now let's look at the sampling techniques. What are sampling methods? There is probability methods and non-probability. Probability, as an example, if you had a population of 100 people, each person would have odds of 1 out of 100. So the chance of something happening of say the sample of 100 people, where 1 out of 100 needs to be selected. So 1 has a probability out of 100. That means, or 99 literally. So out of total 100 sets or 100, let's say, individuals, the chance of 1 being selected is 1:100. So the ratio is 1:100, and the chance is also 1:100. And that is a probability of something happening. Okay. Now, the number 1 means that 1 is a selection, or 1 has to be taken out as a chance out of 100 for someone to get selected. So that value 1 has become the probability, and 100 is the sample size. A non-probability is when you choose something, you choose your sample, it's a predetermined, you know what you have to look for and make a selective decision or what to include in the sample. That's non-probability. Simple random. So the probability sampling has different methods. One is simple random, the other one is stratified, systematic, cluster, and multi-stage sampling. Non-probability is on the right hand side. Under this, you could see it is convenience oriented, purposive, quota based, snowballing, and volunteered. These are just the title, or you could say the kind of, expressing through these headings or these titles, we understand if it is probabilistic sampling or non-probability sampling. So in the exam, there could be a question that says, what is the nature of stratified sampling? Is it probability sampling or non-probability? And you would say stratified is it's a kind of a probability sampling. Now, simple random probability sampling, as I said, is a chance of anything happening. So simple in the head and tail would be 1:2, and the chance of either head or tail happening is 1 out of 2. So the chance is equal. It's 50-50, where heads would have a 50% chance of showing up and tails would be another 50%. So half and half chance of any of these two happening. That's simple random sampling. Stratified sampling, we will look at over here. And you know why we use sampling? As I told you, that we cannot chase after the entire population. We cannot consider the entire population for creating any kind of surveys or to conduct observations. It has to be limited, confined to certain numbers so that it is physically possible to actually collect that data from them. So for that reason, we have to look at sampling, and sampling has to be rationally justified. Like it has to have some attributes and some homogeneous mix that makes it representative of the population. Okay. So one of the probability sampling methods is called stratified sampling. Just give me a moment. Just have to adjust the temperature. It's getting too cold for me. Hold on. Thank you. Stratified is actually derived from the word strata. What strata means is that you are creating a group. Strata is a group, or strata are the phases of a group. So one strata can be split up into different stratas. One group can have different subgroups. So strata is something that has the ability to be further divided into subgroups. They call it strata. Easy for you is just the group. So let's suppose stratified sample means that we are creating some groups that has identifiable attributes similar, or it makes a rationale for it to be selected as a homogeneous sample. So let's suppose we have 1,000 employees in a population, and we have 800 females. This F over here says that there are, out of 1,000 employees, 800 are females, and male population is 200. So this is not a strata yet, but let's suppose it is a sample that you've taken out. Out of 1,000, you are looking at this distribution, but you need a sample taken out from, let's say, the entire group, and you want to divide it into stratas. So splitting it, you find that one strata is for females, which means that you are going to select 80 out of 800 just to shorten it and make it into a sample size. And your sample size is presumably 100 out of the population of 1,000. And you want to maintain a ratio that makes it a kind of rational sampling to split between male and female by keeping the ratios intact. So let's suppose 800 to 200 means what? 8:2 out of 10, or it could be if it is to be a total of 100 individuals, you would split it as 80 for females and then 20 for males, so that the total sample size is 100, yet it is representative of the population because it is 80% females and 20% males. So what you have done is that you have actually brought this into stratas, or split it into two stratas, one for 80 females and the other one 20 males. And then when you have collected these two, you've done it randomly, like you are not being very specific on females, like what should be the age of the females or what should be the qualifications, but rather we're just dealing with the numbers as male and female for simplicity. Whereas the female size can further be divided or split into another strata or substratas. And same thing with the males, you can do more stratas out of the strata that you have created, the first one. But for simplicity, we have just got two stratas. Now what we do is we combine it together to make it a set of 100 employees. And these two are called stratas, but when you combine it together, it becomes a simple sample size. But the methodology you have adopted in making it into a stratified sample is that you have created stratas first, like these two, and then you've joined them together. So you are now representing a mix or a sample that truly is representative of the population of 1,000, yet the sample will keep the ratios intact so that it is kind of maintaining that that ratio. Okay, so this is stratified sample. Then we've got cluster sampling. That's another technique. Cluster means that it is a cluster of different locations or geographically distributed sets of locations that would have employees or departments that are similar or have similarity with each other. So if it is a production department from, let's say, one location in Stanford, the other location of production department or senior management in, let's say, in the East Coast, somewhere in New Jersey location, and and so on. So all these spread out locations would have a sample that makes the collection of information confined to the locations that are kind of built into or set as a cluster, rather than going into all the locations of those production department everywhere globally. You have made a selection, let's say North American branches, or any production line that is in North America is said to have created a cluster. And the cluster has to have the attribute that makes the selection as if it has got similar values or similar attributes. So if in the first group in the diagram, you could see that there is one location that has 23 employees from production. The second group from another location has employees from production department, supervisors or foremen, but in production. And then you have other workers in another set or another environment, but also in North America. These are said to have created a cluster, whereas we've ignored every other location, as you could see, because physically it's not possible for anyone to just, you know, just make those samples so random that it doesn't have a strategy or it doesn't have a kind of uniform method that you have applied. So for the uniformity of method and for the selection that is representative of the entire setup of that company or that production house is very difficult to reach. So you have actually identified a cluster which you will use as a sample. So this is where we had, let's say it says has 10 offices across the country, all with roughly the same number of employees in similar roles. You don't have the capacity to travel, blah, 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 you know, sampling to 3 offices. These are your clusters. So this is how we are going to do the cluster sampling. It is kind of a probability sampling. Probability, all the time you have to think of probability then when you have chosen something out of a set on random basis, yet the randomization has some methods attached to it or attached to how you select. So that randomization has got some commonalities, and therefore being randomized sampling, it is also considered to be classified under the probability sampling. Then you have probability sampling techniques, that is multi-stage sampling. Multi-stage sampling, like I told you about the stratas. Stratas are split up into subgroups when you your one population set is not representative enough, that it needs to be split up further at different stages. It is called multi-stage. For example, let's read this first. Let's say you wanted to find out which subject your school children preferred. A population list of all school children would be nearly impossible to come by. So we divide the population into states and take a simple random sample of state. So first you're going to select the states, and then from the states you're going to do another simple random sampling, or you can even do stratified sampling, but it is in stages. That means that you are taking the entire country. From there you're going to create first set of samples for the states that needs to be, you know, randomly selected, and from those states you're going to do another stage of sampling that will take out the schools or the divisions, or I think you have counties and all those places. So those are going to be figured out, and that figuring out would depend on the sampling and the sample size. So the second stage happens, and so on. So if you look at the diagrammatic scenario, you see population split into school children's too many. So in the first stage, you're going to choose the states. From the states, you're going to select counties, and from counties, you're going to select student sample. And then it can go from the stage 2 to stage 3 to stage 4 to stage 5. So a simple random sampling started from the state, went to schools in the state selected. So this is another sampling, which is stage 3. Then the third sampling is from these schools that you have selected. Student sample is obtained. From student sample, you can go and obtain more. So it is stepwise. That means that you don't just take the population and then all of a sudden make a randomization to select students out of the entire school population. It wouldn't justify or wouldn't make sense, because here the randomization is way too much, and the selection or sample size may not be representative of how you would want to use this data, without having a process that defines how the randomization or the sampling sizes are obtained, without putting some sort of a form or a format that goes from one stage to the next to the next. From the top, it is splitting up into smaller samples, and that small sample goes even small until you reach the sample size that you need. But for you to bring it from the main population directly is not considered a good method. So it has to be following those stages, and those stages have to be defined and sort of put in your research as the process that you have adopted in collecting those samples. So these are stage-wise, multi-stage sampling. Okay. What are non-probability sampling? Non-probability sampling, convenience-oriented sampling. Convenience means that somebody that who is part of the population around you, easy, convenient to get, could be some people from your own office, from your own network, from your own profession, but then there is an element of bias when you are selecting those people, and it is not considered to be truly justified if the sample is too selective, where you are actually making a decision on including people that you know to be representative of some sort of observation or search. So that is convenience oriented. Purposive means that there is a purpose to where you are selecting people based on certain criteria, but again, it is a kind of proactively getting people or calling on people to become part of your sample, and that would mean that you probably, again, the bias is playing a large part into purposive samples. So purposive also means that somebody else that you have selected, let's say, like right here in the diagram, you could see that this one in the gray color could be the researcher, and this researcher has asked somebody close to them to find another person that they know, and so another person is added, whereas another person adds yet another person. But the important part is that these ones that are in green color right here are the people that you know, or the people that you have used previously as sample gatherers, and then they have the tendency to repeat the same individuals to be included as previous observations for some other issues or some other sample, or something that is part of your sampling, but that could be a repeat of the same. So that is not a very good approach as well. Snowballing happens when third person or outside parties like professional companies that do research work, they are handed over the recruitment process. Or recruitment means that they're recruiting the sample sizes, not the sample size, but the sample itself. So those people have the network which sort of collects people as a profession, and it creates a snowballing effect, which means that generally these people are paid large amounts of money to become part of the sampling. And the snowballing means everybody volunteers, hey, I want to be part of it, I want to be part of it, and they might not be giving you the correct sample because here you don't have a control over selection like in the direct sense, where it is being asked by third parties to do it for you, and there would be this element of people voluntarily becoming part of your research only because they're getting paid or there is some sort of transaction involved. Volunteered sampling is more appropriate when you advertise or you are looking for people who have certain similar things or similar attributes, but the only thing is that it works in groups. So when you're doing volunteered sampling, let's suppose you have 3 volunteers and they get the 4th one. Again, you have another set where the 4th one would have a relationship with another group of people that they would be collecting or they would be gathering for you. So it is all about the relationships or the different ways in which the relationship is created between those who are recruiting or who are the researchers and collecting the sample, and the third party, which could be professionals, volunteers, or those that are known to others, or one volunteer would get other volunteers. So that sort of is a non-probabilistic, because it is very hard for single researcher to find a sample without random sample usually is for larger studies or where you need a huge sample or more people. But non-probabilistic sampling usually is when you're doing a closed group experiments, or you are doing research on a closed number of people who are not too far many, and you're not looking for a lot of commonality, but rather something that is not easily considered as available characteristics in most people. So it could be in clinical science, for instance, or clinical research. It could be some peculiar or very unusual disease of some sort where people are using as kind of a medication which is experimental or new, and you're doing those kind of studies. Then you do non-probabilistic sampling, because here you have to you have to choose on your own, and it's hard to find those samples. But school children, yes, you can get those samples, but probability sampling is more appropriate. Numbers are higher. So the difference between probability and non-probability is a difference in approach to what methodology you want to adopt, and within each methodology you would discover different methods of data collection or sampling techniques. Okay, data analytics and data analysis we will do tomorrow. And tomorrow is Friday, so tomorrow we'll finish up early. I think we're doing quite well as far as finishing up everything on time, it seems like. So again, I want you to look at the schedule one more time, just to see how much of the classes we have done and where we are at and what is left out. I want to okay. So today we did class 14. Tomorrow we have class 15. So tomorrow we finish up data analytics. On November 8th, which is Monday, and November 9th, there would be the last class. So on the 16th and 17th, we'll be doing internet laws, and we will be doing internet ethics. So those two parts will be finishing up. So by Tuesday, coming week, we'll be done with the course. And then over this weekend, I'm going to prepare the practice questions for you and give it to you on Monday. I'll put it in your Dropbox. It will go in this folder. here, CIRS practice exams. This is where I'll put it, okay?
Okay.
So I'll let you all go now. I think it's too much information, isn't it?
It's quite a bit, but it's good. It's good.
Because you see, this is the thing about becoming a researcher, and with the course you've taken with us, we have actually, you know, our consideration is not really to prepare you for just being able to find online information, but really to go beyond that and to have the ability to use it in a professional way, so that you would know you know, how the conventional research methods are to be applied in order for you to actually make that search or those data you collect useful, and so that you can even present it and build it into a research report. That's the end goal. And one of the things that you are learning right now is the essential parts, which involves collecting, sampling, you know, analysis. And the last thing is the legal issues that you should be aware of, privacy issues, reuse of the data or information. Kathleen was asking about it. Copyrights, intellectual property, infringements that you have to be careful about, disclaimers, some of the data collection, legal requirements, you know, all of that. So that would be covered on Monday and Tuesday, and this sort of gives you an overall well-rounded view of how a researcher should be, you know, not only collecting but using the information. So truly you can say that you've actually are able to do independent research and become a, you know, independent consultant or research analyst. This is the purpose of CIRS. So thank you very much. I appreciate your patience taking around with me and attending the class. I'll see you all tomorrow. Okay. Have a great evening.
Thank
You too.
you.
Thank you.
Thank you all.
Right.
Bye-bye.
Bye.
Bye-bye.
Take care.
Bye.